Good morning all. So in today's class we'll look at one more problem on circular commutation, and then we'll introduce what is called combinations. So before that we will see a principle called principle of complementation. So principle of complementation states that, so in short we'll write a CP. So if A is a subset of a finite universal set U, then the cardinality of U minus A, so cardinality of U minus A will be equal to cardinality of U minus cardinality of A. So if you have a given finite universal set and A is a set, then U minus A is called as the complement of A. Then the cardinality of complement of A will be equal to cardinality of U minus cardinality of A. So we will use this result in the coming problem. So the question is, in how many ways can 5 boys and 3 girls be seated around a table if, so the first subdivision is there is no restriction, and the second part is boy B1 and girl G1 are not adjacent, and the third subdivision is no girls are adjacent. So let us see the solution. So there are 5 boys and 3 girls. So the first part is there is no restriction. So when there is no restriction, so 5 boys and 3 girls can be arranged around table in, so that will be 8 minus 1 factorial ways. So that is equal to 7 factorial ways. So that is the usual circular permutation. So when there is no restriction, it is arranging n objects along a circle. So here n is equal to 8. Now for the second part, B1 and G1 are not adjacent. Now for this we will use the complementation principle. So by complementation principle, so the number of arrangements in which boy 1 and girl 1 are not adjacent will be equal to the total number of arrangements. So cardinality of U minus A kandupidikkanengil, that will be cardinality of U minus cardinality of A. So cardinality of U is the total number of arrangements, and A will be the number of arrangements where they are actually adjacent. So first let us find the number of arrangements in which they are adjacent. So the number of arrangements in which B1 and G1 are adjacent. So when they are adjacent, so they will be considered as a single entity. So B1 and G1 will be considered as a single entity, and there will be again അപ്പം 8 ഉണ്ടായിരുന്നു മൊത്തം. So it will be considered as 6 plus 1. So 6 plus 1. So the number of arrangements will be, so total it is like arranging 7 people. So along a circle that can be done in 7 minus 1 factorial, and B1 and G1 they can be arranged among themselves in 2 factorial ways. Okay, so that will be equal to 6 factorial into 2. So that will be equal to 1440. So therefore by complementation principle, so the required arrangements will be, now take the difference. So we have got the total number എന്ന് പറഞ്ഞാൽ നമുക്ക് ആദ്യം കിട്ടിയത് തന്നെയാണ്. അപ്പോൾ 7 factorial minus 1440. So that is going to give you 3600. So that is the required number of arrangements. Now in third subdivision, you have no girls are adjacent. So no girls are adjacent. So first what we need to do is first arrange all the boys, and girls are seated in the places between them. Now so if you look at the number of boys, so they are 5 in number. So the required number of ways will be, so boys can be arranged in 5 factorial ways, and remaining there will be, so you have boy 1, B2, B3 and B4, B5. So remaining there will be 1, 2, 3, 4, 5 positions. So there are 5 positions in which girls can be seated, and there are 3 girls. So when you take the first girl can be seated in any of the 5 position, and the second girl can be seated in any of the 4 position, and the third girl can be seated in any of the remaining 3 positions. So this is the required number. Okay, sorry, there is a mistake. 5 boys ne adi arrange cheyna, that is 5 minus 1. So it is 4 factorial. So that will give you again 1440. So that is the required number of arrangements. Now let us see the definition of combinations also today. Now we have seen the definition of permutation. So permutation is arrangement of objects along a row, and in permutation the order matters. Now what happens in combination is, combination is just the number of selections. Okay, and in combinations you are simply selecting the object, and the order is immaterial in the combination. Or combination can be considered as finding the subsets. അപ്പോൾ നമുക്കൊരു സെറ്റ് എ ബി സി തന്നിരിക്കുകയാണെങ്കിൽ നമുക്ക് അതിൻ്റെ അകത്ത് 2 സബ്സെറ്റ്സ് കണ്ടുപിടിക്കണം. ഓക്കെ, സോ വെൻ ഐ ടേക്ക് എ ബി ഇസ് സെയിം ആസ് ബി എ. സോ 2 സബ്സെറ്റ്സ് എടുക്കുമ്പോൾ നമുക്ക് കിട്ടുന്ന 2 സബ്സെറ്റ് എന്ന് പറയുന്നത് എ ബിയും എ സിയും ബി സി ആണ്. സോ യു ആർ നോട്ട് ടേക്കിംഗ് എ ബി ആൻഡ് ബി എ. സോ combination is basically forming the subsets, and so the order is not important. അപ്പോൾ പെർമ്യൂട്ടേഷനിൽ നമ്മൾ എന്താ ചെയ്യുന്നതെന്ന് വെച്ചാൽ, പെർമ്യൂട്ടേഷനിൽ നമ്മൾ ആദ്യം സെലക്ഷൻസ് നടത്തുന്നു, ആൻഡ് സെലക്ഷൻസിനെ നമ്മൾ അറേഞ്ച് ചെയ്യുന്നു. അപ്പം ഞാൻ 2 പെർമ്യൂട്ടേഷൻ ആണ്, എ ബി സിന്ന് 2 പെർമ്യൂട്ടേഷൻ എടുക്കണമെങ്കിൽ, സോ ഇഫ് ഐ ചൂസ് എ ബി, ഞാൻ എ ബിനെ എ ബിന്നും റെപ്രസെന്റ് ചെയ്യും, ബി എന്നും റെപ്രസെന്റ് ചെയ്യും. സോ യു മേക്ക് ദ സെലക്ഷൻ ആൻഡ് ദെൻ you arrange it among themselves. So that is the difference between combination and permutation. അപ്പോൾ നമുക്കൊരു permutation കിട്ടണമെങ്കിൽ ആദ്യം selections നടത്തുക. ആ selectionsനെ arrange among themselves. So if you are selecting R objects you can arrange among themselves in R factorial ways. So that will give you the number of permutations. So that is how the combinations and permutations are connected. So let us define combinations and how combinations and permutations are connected. Okay. So let A be a set of n distinct objects then a combination of A, as we said, is simply a subset of A. And the number of R combinations of an n element set A is denoted by, so the notation for combination is CNR. So in permutation, ordering is important. And in combination, the ordering is immaterial. So the ordering is not given any importance as it is like forming subsets. Now let us look at how do we get the combination. Now when you look at permutation, so every R permutation can be obtained in the following way. Out of n distinct objects. So consider you are having n distinct objects in a, you need to find the number of R permutations. So it can be done in 2 steps. So step 1 is form all the R combinations. So ആദ്യം different R combinations, R distinct elements വരുന്ന എല്ലാ sets choose ചെയ്യുക. And then now arrange all R combinations among themselves. So when you do this 2 steps, you are going to get an R permutation. അപ്പോൾ നമ്മൾ ആദ്യത്തെ സ്റ്റെപ്പ് എന്ന് പറയുന്നത് that is form all the R combinations. So out of n objects, you have to select R objects at a time. So that is CNR. And CNR നമ്മൾ out of in one entry of CNR there are R objects, and R objects can be arranged among themselves in R factorial ways. So this product will be equal to PNR. So that will give us CNR is equal to PNR by R factorial. So that is n factorial by n minus R factorial by R factorial. So which is going to be the definition of CNR. So this is the number of combination of n different objects taken R at a time without repetition. So this is how the number of combinations obtained using the number of permutations.